Today we are looking at 12.2 notes. This hopefully will be a review for you. So we're going to start with the unit circle. So a unit circle is called a unit circle because the radius of the circle is 1 unit. Then we're going to put this on a coordinate grid. And what I want you to notice is that if I pick a point, let's say x comma y, I can draw a radius. So this is a radius of 1 unit. And if I drop a perpendicular to create a right triangle, and this is to the right x and up y, here's something super cool. If you remember your SOHCAHTOA, the sine of theta is the opposite side over the hypotenuse, where sine theta is y. Cosine theta is adjacent over the hypotenuse, so cosine theta is x. So here's kind of the big idea. Every x comma y along the unit circle goes cosine theta comma sine theta. And then let's look at tangent theta is y over x, or that's sine theta over cosine theta. Okay, these are things you do need to remember. Then if I have Pythagorean theorem, x squared plus y squared equals 1 squared, well, then we would say that's cosine squared theta plus sine squared theta equals 1. That's referred to as the Pythagorean identity. A quick note here is if I'm wanting to square the sine function, we put the little 2 above the n. And for cosine, we put above the s, and in tangent, we put above the n. But it means sine theta times sine theta. All right, so if I want to go over my exact values one more time, let's take a look. If I had a 30-60 right triangle, cross from 30 is 1. The hypotenuse is double, and this is radical 3. So the sine of 30 is 1/2. This is radical 3 over 2. And this is either 1 over radical 3 or radical 3 over 3. Let's pop to sine 60 degrees. That's radical 3 over 2. This is 1/2. That's radical 3. 45-45, let's draw this one. In a 45-45, the legs are equal by Pythagorean theorem. A squared plus b squared equals c squared. The hypotenuse is radical 2. So this is 1 over radical 2. This is 1 over radical 2. And this is 1. You really need to have this table memorized. So if you don't know these, create a Quizlet, create index cards, do whatever you need to do, and do this every single day. Do it 5 days a week, where you are constantly looking at these. You really need to know, like, what's the sine of 30? Oh, 1/2. What's the tangent 45? 1. Like, it needs to be a quick recall for where we are headed. All right. Just because I'm kind of picky with how I evaluate, whichever way you learned is absolutely fine, but some teachers teach this a little differently. So I'm going to show you my method, and you can use whatever method you like. Just not using a calculator, okay? No calculators. So here's what I do. If I want to evaluate in example 1, I make a sketch. Okay, so I'm going to make a sketch of my angle. So let's look at 210 degrees. So 210 degrees is into the third quadrant. and it's 30 degrees in. So this is going to create a 30-60 right triangle. So across from 30 is 1. This would be 2, radical 3. So I determine the reference angle, and then you're going to do the trig function for the associated reference angle, and then do all students take calculus. So the sine of 30 is 1/2, but the sine of 210, because it's in the third quadrant, sine and cosine are negative down here, and tangent is the only one positive. So the sine of 210 is negative 1/2. Another possibility is you could say that's left and down, so it was negative 1/2. Any way you slice and dice it, it'll be the same. All right, negative 5 pi over 4. Okay, let's make a sketch. All right, when I go to do this, kind of watch me here. A negative is going to go clockwise in rotation. So here's negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, negative 5 pi over 4. Let me go through that one more time. You do want to learn how to work in radians, okay? Pi over 4 is 45 degrees, okay? It really is 45, so that's why I know it's halfway. So here's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, that's pi, and then 5 pi over 4. So this is how I know where I'm going. And then I know that that's a 45, 45 right triangle. So I go 1, 1, radical 2. I'm left but up. So then my cosine, negative 5 pi over 4, is adjacent over hypotenuse. You do not have to rationalize for me, and you do not need to rationalize on the IB exam. But if you check the back of the book and they have negative radical 2 over 2, please be comfortable that those are equivalent. All right. So what I want you to do now is try letter C on your own. Tell me what you get. All right, so I'm going to try this. 5 pi over 3 is here. That's a reference angle of 60 degrees. So it goes 1, 2, radical 3. I'm right and down. Tangent would be negative radical 3. Okay, pi over 3 is 60. 5 times 60 is 300 degrees if you have to go with degrees. So you're 60 degrees away. When I say reference angle, the reference angle is how far are you from the x-axis. Never, never do we do from the y-axis. It's always from the x-axis. All right, letter D. 2 pi, if I put a denominator of 4, would be 8 pi. So this is now more than one time around. So this is equivalent if I subtract 8 pi. So if I actually were to draw this, this is one full time and another. So then that's a 45, 45, 1, 1, radical 2. So that is 1 over radical 2. All right, example 2. Without finding theta, find cosine theta if sine theta is 3 over 5. So what I'm going to do is I'm going to use SOHCAHTOA. I have 3 over 5. And if you do a squared plus b squared equals c squared, that's 4. So cosine theta is 4 over 5. Easy peasy. All right, last example. Solve the equation sine theta equals radical 3 over 2 for theta between 0 and 2 pi. All right, all students take calculus. I should have two answers. Okay, so we should have two answers here because sign is positive in the first and the second quadrant. Do not touch a calculator. This is where knowing these values, where does sign equal radical 3 over 2? That's a reference angle of 60 degrees or pi over 3. So it's, change colors here. So it'll be 60 degrees in here and 60 degrees in this way. So this would be 60 degrees or 120 degrees because it's 180 minus 60. Well, that's pi over 3 because it does want it in radians. Okay, if you put this on the IB exam, you're going to lose points for accuracy because that's if you don't put it in radians. All right, that finishes the notes.